So different classes of fire. There's a universal system that will use letters, and it's an international system that hopefully uses letters, colors, and symbols to select the correct fire extinguisher, because not one size fits all when it comes to fire extinguishers. Now there is an A type of fire, which is the most common, probably what you are thinking of when you think of a fire. That is going to be something like a trash fire, wood, paper, cloth. Now, if something's a flammable liquid like gasoline, then it's a B class fire. Now, if it's got any kind of electrical equipment, it's going to be a C class fire. Now, we keep a D class fire extinguisher in our classroom, and it's really heavy and really big. That's because we keep flat combustible materials, combustible metals in our classroom. Now, uh, A, B, and C type fire extinguishers will not work on this kind of stuff, so that's why we use that. And then a K style fire extinguisher is about cooking oils, and that's specifically for that. Now, there are many different types of fire extinguishers, and some of them will be a combination of these different classes, but that's what we use. So go ahead and identify these classes right here. Go ahead and practice. All right, hopefully you got these answers. You got gases and oils were B, wood and paper were A, the energized electrical sources were C, and flammable metals were D. So when you use a fire extinguisher, you're going to follow what we call the pass system. The very first thing you're going to do is you're going to make sure you keep your back to a clear and escape route. So you never turn your back on a fire. You always are facing it so that you can back away. You always want to stand 6 to 8 feet from the fire. You never know when it could just go catch another fuel source and go completely crazy. And then whenever you are ready to pull the fire extinguisher, you're going to pull the pin. You're going to aim the nozzle. You're going to squeeze the trigger, and then you're going to sweep at the base of the fire. All right. So this is essentially the best way, the best little way I showed you. Now, she's got a teeny tiny fire extinguisher, the kind they sell at Walmart, and it's doing a pretty good job on a big fire. Now, those fire extinguishers only last about 10 seconds, so she would probably need a bigger one, and she would be wanting to back away as soon as she ran out. So that's why you never turn your back on a fire. We're going to move on to the NFPA diamonds. So the NFPA stands for the National Fire Protection Association. So NFPA diamonds look like this. You've undoubtedly seen them posted somewhere on the road or on a vehicle or on some kind of storage. And they have these numbers and colors. And it's pretty simple, easy to understand. Now, there are many different types, and there are also some what we call text dot placards. Now these are for Texas, and they have a specific number. Now this number will represent what specific chemical is in there. So all first responders have this little guidebook that tells them what number matches up to what chemical, and it gives them the guidelines for fighting a fire or dealing with that chemical. So um, now there are some other ones here that are like the flammable gas, like the orange ones are like explosives, yellow ones are usually oxidizers, and then red ones are things that are flammable. So if it's yellow and red, that's pretty dangerous. Now, white ones are going to be some kind of special thing. Either it's um, kind of uh, probably poisonous or hazardous to your health or maybe your skin or maybe the environment. So there's a rating scale from this, and the rating scale goes from a 0 to 4. And 4 is the most dangerous, and it means that it can be lethal. And 0 means that there's essentially no hazard. Okay, so it just goes on that grading scale. Remember that water will still even have a 1 somewhere. So make sure you take these with a grain of salt. But understand that there are some extra ones. Sometimes they have to add a little extra rating symbol in here for alkaline, which means that it's a base, acid, which means that it's the opposite of a base. It's the opposite end of the pH scale. There's a corrosive, which means it eats through your skin or it eats through objects or metals. Oxidizing, which means it will burn and it will produce its own oxygen. So some chemicals will do that. You can't choke them by cutting off their air supply. They'll produce their own oxygen. Radioactive is radioactive. Some of them do not react well with water, so they have a W with a line through it. And then reacts explosively with water, which would be W with a line through it and ox. Okay, so that's a dangerous one. So so what would be the worst hazard for A? Hopefully, you said that it would be the fire hazard. I didn't go over that. So the red hazards are for flammability, the blue hazards are for health, the yellow hazards are for reactivity or instability, and the white hazards are some kind of special. Okay, so 4 is pretty dangerous. It's very flammable. It's quite reactive. It's somewhat toxic, and it doesn't react with water. So I would stay away from A. Now I would really stay away from B. That's radioactive and all types of messiness. Now C seems to be very poisonous and very corrosive, but not flammable. And then D seems to seem moderate with precaution. It seems somewhat poisonous and somewhat flammable. And then right here, sometimes you will see this on your test, since I can't print tests in red in color. You'll see actually blue, red, yellow, and white. All right, so just be aware of that. So for your safety labels, there's the MSDS forms, which is what we used to call them. They used to stand for Material Safety Data Sheet. And then for GHS labels, which is the current system, it's called the Global Harmonization Standard. They're the same thing now, and they serve the same purpose. Essentially what they're doing is they're informing you of what hazards this chemical has. So each chemical has its own GHS, and this is what propyl alcohols will look like. So here you have the product identifier, you have the signal word, you have its hazard statements, you have its precautionary statements, its supplier, and also the pictograms that are associated with it. Okay, so these pictograms are interesting. This means that it's an irritant. This means that, or caution, this means that it's an oxidizer. This means it's corrosive. Sorry, it doesn't mean it's an oxidizer. This doesn't mean oxidizer, it means flammable. My bad. Here the pictograms are what you have here, and you're responsible for knowing them for your test. Explosives are cool, flammable liquids are cool, oxidizing liquids, compressed gases, and corrosive to metals. And then acute toxicity, skin corrosion, skin irritation, and then an aspiration hazard. And then this one says it's hazardous to the environment. So, if a lab group were using hydrochloric acid to perform a substitution reaction, which precaution would not be a concern? Here's hydrochloric acid's material safety data sheet. I'll give you a second to think about it. Okay, you should have chosen B, because hydrochloric acid is not flammable. All right, flammability is 0. Now, health is severe. You should definitely not drink it, even though it actually technically already is in your stomach. And it is reactive, and it is very corrosive. All right, that's going to be it. Have a great day.